What we have here is simple, real-valued cellular automaton implementing a simple reaction diffusion system, but one in which the rule parameters vary across the array. What's interesting here is that we see the stripes, essentially the same kind of stripes arise in two places, but in different colors. In the lower left corner, we see the stripes arise essentially in cyan color, and above we see in blue, and in the upper left we see purple stripes and white background. And then there's a chaotic region where they mix, and this is actually the interesting region. And in the transition between the order and the chaos, you see the spirals or the rotors. And so that the transition between the order and the chaos is actually, those two transitional regions are actually the very most interesting. But I'm just, it sounds like you're just testing the streaming, because I haven't done it for a few weeks. So now we'll pop over and see how the stream looks. And it looks like those two transitional regions are actually yes, so it seems to be working. Unfortunately, OBS on Linux does not yet allow me to monitor the audio as I'm pumping it out, which I sort of would like to be able to do. Yeah. What's interesting is that you sort of get a mirror image across the strip of chaos of the spirals and then the stripes, but in different colors representing different things. And the code's quite simple. But I've been looking at Mario Klingemann's stuff. In fact, why don't I pause this and I'll just kill that because it's putting a load on the processor. I'll come over here and I will, on my stream, I will show you what I'm talking about. Mario Klingemann is a Google artist in residence. So we're going to look at some of his YouTube videos. Okay. So this is one that interested me. And this one plays music. I want to make the question is, does that desktop audio make it to my stream? So let me go over and see. Yes, it does. Excellent. Okay. So this is a cycle GAN. But this one is more relevant to the automaton I was showing. So the resolution is not great, but here he there you can see the stripes. That's such blurry. You can see the stripes. The stripes are similar to my cellular automaton, and then the faces are from something different, and they're mixed and competing in an interesting way. And so this guy's work is what made me realize that, yeah, I'm going to have to get into this CycleGAN deep AI network stuff. But I just wanted to quickly show that because it okay, so CycleGAN is where you have two, or I suppose more, generative adversarial networks. You have chain networks that are like in a feedback loop. And so I had this idea, what if I had one of these, let's see, how can I make it to look like I'm pointing at that thing? Okay, that thing, right. If I took that and had also another cellular automaton and had the two of them slave together in a feedback loop, I might be able to get more interesting phenomena than I could with just one. That was my idea. Especially if I combined it with one of these generative adversarial network deep learning jobbies, so that I actually had faces, for instance, or flowers or eyes, or because what I noticed in that last video of his was that you had the stripes running, and every time one of these little rotors, I don't know if it was a rotor or some other, or bifurcation, some other kind of split forming. Anytime you had action starting to happen in the stripes, the face generator grabbed it and made a face out of it. And then it would like surge away and blossom into more stripes. But now when I say that, we'll look at the code. When I say that this is simple, so it is simple. Have a look. So this array is 600 by 600. That's specified here. Size equals 1. So kill it. We will say make the array 300 by 300. Put the output size pixel to a 2 by 2 pixel block. Free, open. Okay, so now it's faster. But you won't see the interesting variation because most of the interesting stuff is off the image. Because it's... But let's fix that. Okay. So... here's the heart of the cellular automaton. You have the generation, you have the neighborhood, the code that calculates the neighborhood for the mesh. And then there are three parameters, A, B, and C, and they are used in two difference rules. and then the values are clamped between 0 and 1, and that's it. And then you go through the array and cast those reals to integer values, 0 through 255 RGB values. Boom. Okay, so there are two rules. One rule basically you have, there are two meshes here, the same size. And you can think of one as being a poison, mesh 2 as being like a poison for mesh 1. And the first rule grows mesh 1. Mesh 1 is a component that catalyzes the growth of itself. The more of the mesh 1 there is, the more it grows itself. And the second rule says the more mesh 2 there is, the more it fires this rule that poisons mesh 1. So it's a simple, there's some name for it. It's a simulation of that simple, two component cellular automaton you can do with chemicals in a dish, in a petri dish. But the interesting thing is I've got it tuned with parameters A, B, and C. And I've got those parameters varying across the mesh as I step through it, I and J. And I set A and C for each I value. I set A and B. And then I step A for each I value. So anyway. So let's change 5. I'm just kind of guessing here because I don't have a good intuitive grasp. I know the action's happening down to the right because it was all tuned for okay, so I can free this and it does not crash the system because I put a, it would in fact crash the system, except that I put a cleanup procedure in many years ago, but that doesn't matter. Okay. So I failed to get into the interesting screw it. Let's just go back to and store, compile. Okay. Oh, I forgot to mention that I think that I initialize it. Let's see. I initialize it randomly. Well, this is interesting. Yeah, so maybe maybe I can get interesting behavior if I make much smaller array sizes of these, but chain multiples of them together. Maybe at varying time scales too. kind of doesn't look good. I have like 3 colors going on here. That's why it looks kind of grainy and spackly. It looks better when they're just 2 colors, like down in this region here. But I think that I won't see as much behavior if I take out the 3rd color. Let's see. I believe that's right. Yeah, I know that's right, actually. I know that's right. I don't have to try that. I know that's right because I can see the 3 colors. Let's see. How should I change? All right. I will just make it so it is much less densely seeded. And it might be fun to look at. H-top, see how our cores are doing. Oh, okay. It's not going to tell us anything because OBS, the streaming software, is using the cores, so I can't see the core. The core that's running 100% is the core that's running the automaton. The other ones are all doing OBS stuff. And you see that OBS is like, in fact, using a lot of the cores. I mean, I'm running 8 cores, 16 hyperthreads, and it's running like 50%. Wow. Okay. Well, that's okay. This is the nicest I've seen, because what I like here is that I'm getting this striping so that you see parallel with the y-axis. I see stripes here, here of okay. That is interesting. Okay. Alright, I gotta exit. I can't do this to my poor cores anymore. Alright, I can hear the computer straining. It's like, John Braun competing against the steam drill.